that was the foxhole one.
That was the foxhole one.
All right, hello. I'd like to welcome everybody out there to Amateur Radio Roundtable. I'm Tom Medlin, W5KUB, and we got some great stuff to talk about tonight. First, let me just mention to you out there, if you're listening to us on shortwave on WBCQ on 7490, this show is about ham radio, amateur radio, and if you're interested in ham radio, stick around and join us. If you have internet access wherever you are, you can always join the show by going to w5kub.com. And you can join the show, join us in the chat room, and you can actually communicate with us and all the other co-hosts and guests while the show's going. So we'd love to have you. The 40-meter net tonight started off slow, but toward the end we started getting a bunch of pileups in there. I don't know what happened. I don't know if the band opened up or what, but we had some good check-ins tonight. And I just wonder if we have anybody new join the show tonight just because of maybe the 40-meter net. Hey, if you're new tonight in our chat room, let us know. We'd like to say hi to you. Hello, thanks for being with us. And let's see, what else is on my mind here tonight? I talked about WBCQ. We'd love to hear from you if you are receiving us on WBCQ International Shortwave. We'd love to get a email from you. Let us know where you're hearing it and how you're hearing it. And you can send that email to tom@w5kub.com, tom@w5kub.com. And let's see, hey, tonight we got Glenn with us, we got Bill back with us, we got our guest Paul with us, another high altitude balloon guy. You know, everybody keeps talking to me and saying, well, you know, why can't you put a camera on that thing? Well, you know, our pico balloons, the total weight's about like 15 grams, and we just don't put a camera or a battery on there. And but tonight, per your request, we're going to see pictures of some high altitude stuff over 100,000 feet by another high altitude balloon guy. That's Paul Verhage KD4DTH, and also Bill Brown. As all of you know, Bill is also famous for his high altitude balloons and his large payloads. Let's just jump around the room here real quick and see what's on the mind of Glenn and others. Glenn, how you doing, Glenn?
Oh, hanging in there, hoping it snows or something. I need a break.
You're hoping it snows?
Yeah. Oh, I love it this time of year. No, one of the things I was saying, I'm just now finishing up on the book.
Yeah.
And one of the latest projects, this is actually a radio teletype, a RIDI reader and display. And it's just 3 chips and the display.
That's pretty good.
Put together and working this afternoon. That don't have it in a box yet.
Is that going to be in this book or another book?
That's going to be in this book. This is the last planned project for this book.
Okay, well, that's cool, man.
So my target right now is, assuming everything goes as it's going, I'll have the entire book wrapped up by this weekend for sure.
All right, well, we're looking forward to you finishing that book. I know you're trying to wrap it up there.
I need a break.
Yeah, well, let's see. Let's see, Bill. How you doing, Bill? Come in here, Bill.
I'm doing good. Just following your balloon as it crossed the international date line. So it was quite exciting to see it actually cross the date line and go from east to west. So, but it was flying from west to east. So.
But you know, we on our other flight, we gave the ants a certificate for crossing the date line. We're not doing that this time. You know, they've already won that.
And you were going at some incredible speeds. 160 miles per hour is kind of the average rate of speed. I saw a few readings over 200 miles an hour. So you're in a really fast jet stream ride on your way to the west coast of the U.S.
Yeah, I noticed that until we got about, you know, halfway across the Pacific. Now we're down to 60 miles an hour. I don't know if there's speed limits out there. I don't know what's going on, man. Yeah.
Well, the last, let's see, the last reading was about 15 minutes ago, and it's finally, you actually got down to 2.3 volts on that last reading, right as the sun's getting low, and 2.3 volts is pretty phenomenal for it to be working.
All right. Hang on one second. I'm so sorry. I hit a button here. Let me get this off, because that is not, I'm supposed to have the camera on you. So hang in here a second.
That's all right. We were talking about that.
Well, we were actually talking about that, but all right, I've got to get that guy turned off. Hold on, guys, 1 second. I'm so sorry here.
And it looks like you've got a good flight path back to Memphis. It looks like it's going to go right overhead from the prediction. So you've got your balloon magnet turned on, full power. But yeah, at 7:44 tonight, it was last heard, and it looks like that'll probably be the last transmission for the day, because the voltage is down to 2.3 volts, and you were only going about 35 miles an hour during that last transmission. So you are slowing down a little bit. But for a while there yesterday, you were really hauling.
Yeah, I was looking at the graphs, and the graph showed like 250 max. It showed, you know, kind of averaging 160, and then the lowest was about 60. So I'm pleased with that, and we've had a pretty straight flight too. Not a bunch of curlicues or circles or anything like that, you know.
That's pretty good to fly like that fast without any fuel on board.
Yeah, yeah. Oh yeah. Okay. Well, look, you know, I know that you know Paul. Paul's our guest tonight.
Paul and I go way back.
Yeah.
Been launching balloons together for many years. And he can talk about the Great Plains Super Launch, and I've been to almost all of them. So, and one of the very first ones, but not the first one. I don't think I was at the first one, but he can tell you all about that. It's a great event if you can go to it, and we hope to hold it this year again in person. Last year we had to go virtual, but it worked out really well. The conference, we had attendees from all over the world, and I think, Paul, we had maybe 80 people or more attending remotely.
It's something like that, yeah.
And the talks were phenomenal. So we'll turn it over to Paul, KD4DTH.
Well, Paul, go ahead, man. Pick it up. And I know you got a presentation. You want to show us some things, pictures and different things. I've already looked at it, and it looks pretty interesting to me.
Greg, glad to hear that. So Great Plains Super Launch was something we started back in 2000. It was to do, 2001. It was to do a magazine article for Weatherwise magazine. And it was only three balloon launches at the time, but then 2002, we really kind of ballooned out, ballooned out, and started bringing a lot more people into the presentations. Made it, a 3-day presentation where 2 days initially, where we get together one day to talk technology, and the second day to actually walk the talk or do our launches and go chase them. And starting in 2009, it became a 3-day event where we had some kind of a interesting social science or something event on a Thursday, conferences on Friday, launch balloons on Saturday. That's actually a great way to get to meet people in the art in the sciences of high altitude ballooning. Learn some of the ins and outs, and actually work with people who have done this before. A good learning situation to get into. My interest in near space ballooning started back in 1994. It was October 14th when Sias in Salina, Kansas. And if you are anyone from Kansas, you're going to know Pete. This is mid-state, almost mid-state Kansas. He came to our radio club meeting at the Manhattan Area Amateur Radio Society in Manhattan, Kansas, Mars, and talked about near space ballooning. And what he did is he showed a picture that showed the curvature of the Earth. It looked like it was taken from space. Like, well, how did you do something like that? He says, it involves GPS receivers, microcontrollers, packet radio, and it's a poor man's space program. I'm thinking, those are the four things I'm interested in, and it's all packed into one event. So I immediately fell in love with it. It took me 2 years and 2 weeks and a few days to get my first balloon flight together, launched it, and I've been addicted ever since. At GPL this year, I launched my 200th balloon, which is a small number compared to Bill. But 200 flights so far, and looking forward to another 200 flights before I leave this planet. And just this whole thing with, like I said, it's a poor man's space program.
Well, Paul, Paul, let me ask you a question. I know the balloons that you launch are large, very large, and they probably take a lot of gas. I mean, what's the cost to send a balloon up like that? Our pico balloons are pretty inexpensive as far as the cost for gas.
Sure. Now, the balloons that I do are latex balloons. I don't do the Mylar balloons, at least not yet. I may be doing that soon. I'm more hear about them, the more I'm kind of leaning that way. For me, though, I'm a science guy. I like amateur science. I'm a science teacher, so somehow those came together. Don't know how, figure. But I'm interested in getting high altitude and gathering lots of data. The pico balloons are good for long duration flights, and you do learn something. What's the wind speed? I think you guys do temperatures. You learn something about wind speed, wind direction, temperatures. The function of altitude, but it's over a very narrow band, the atmosphere. For me, I'd like to see space. Now, I can't get to space, but with the latex balloon that I fly and the gas that I fly, I can get a balloon for about $75. It's latex. It goes up, it bursts, it comes down. We go space it, and we launch before right after breakfast, and by lunchtime we've recovered the balloon and we're at a pizza place eating lunch and enjoying what we've done. Gas, we used to use helium gas, and I used to be able to get that for $25 a K tank, about 290 cubic feet or so. This is back in the late 90s. Now helium, with the helium reserve being sold off and all that, price is just goes crazy. $300, I even heard $400 for the same amount of gas at some point. I use hydrogen gas, and for about $75, I can get a tank of hydrogen gas, 290 cubic feet or so. That's enough to do a balloon flight. My consumables, $150 for a balloon flight. Now, I'm restricted with payload weight if I don't have to jump through some hoops for the FAA. And I'm limited to about 12 pounds. So I have to get everything into 12 pounds. No one package on the balloon string more than 6 pounds in weight. It kind of gives me an incentive to design light and effective, which is what satellite builders have to do also. So that's not unique to balloonists. If you want to launch satellites, you have to build light and effective. In a lot of ways, it follows the design characteristics of a space flight. So to answer your question, about $150, about 30 minutes to fill, about an hour and 15 minutes to an hour and a half to ascent burst, and another 45 minutes roughly to landing. We have an idea of where the balloon's going to go. We can predict the balloon flight using weather data. And in Idaho, we have a problem where we are the most mountainous state in the 48. And there's a lot of places that you don't want to land. In fact, most places you do not want to land. So we are forced to drive around to find a good launch site so that our landing site is going to be accessible. So now I focus, like I said, on more of the science side of it, and also I focus on education. I call myself a near space evangelist. I've helped other schools, elementary, junior high, and high school students design experiments and get them launched, and we go launch and chase for them. So that's kind of where I kind of focus at. For me, just to be able to send a balloon into the mid stratosphere, the middle of the stratosphere, and see conditions that are, that are 99% like space and almost nothing like conditions here at sea level. So, and with that introduction, I guess if this is a good time, I could go ahead and show my presentation. Questions before we get started, I guess.
Yeah, sure. Let's go ahead and jump right into it.
Okay. Now let me go ahead and hit my share screen, make sure this is going to work. And I think I'll do this one here. So share that and let me know. You should see the slideshow. Let's see, slideshow. And
yeah, we got it, or we had it.
Okay,
here
good.
It is. Mm-hmm.
Okay, good. Okay. Now I do a lot of other science stuff, and I own a house, so there's a lot of things I could do around the house, and I'm a gardener, so I'm not as much heavily in the near space as I was a few years ago. I've got too many other things that are getting in the way. For years, okay, for me, it was eat, sleep, near space. I mean, that was literally everything that I did. Just wasn't interested in much more than that. Now, like I said, owning a home and gardening and have some air drafts in the house. The furnace is going on too much, so I'm kind of hunting down holes or vents or opens in the house and all that. I'm kind of a little less near space, but still do a lot of near space. So kind of the things I just kind of make everybody aware of is, first off, is where is near space? Because that's not a term that a lot of people hear every day. And then talk a little bit about the conditions you'll find in near space. And when I do that, you're going to see that near space is really so much more like space than it is to what we experience here near at sea level. A little bit about how do we actually get to near space. The nice thing is it doesn't take a rocket or anything like that. Also about tracking near spacecraft, and I'd like to call them near spacecraft. Some people call them stratollates, or there's other names like that. They'll call them balloon sats, or some of the balloon satellites. It's something they'll call them also. We'll talk a little bit about tracking it, and I think your listeners will be interested in that because it's digital radio, it's packet radio, specifically. Also, we talk a little bit about this over Eclipse 3 years ago, and just kind of give you an idea of what kind of data we can collect. So for one thing is, where is near space? So if you start from the ground and work your way up, you're gonna come in and out of different regions of the atmosphere. Number one, we do divide the atmosphere up by the layers, so the troposphere, stratosphere, mesosphere, thermosphere, and then eventually the exosphere. The troposphere is the lowest part, and that's where our weather occurs at, and at 50,000 feet. Now, it depends on your latitude. As you approach the poles, that troposphere gets lower and lower. 25,000, 30,000 feet, something like that near the poles. And that's like I said, a lot of convection goes on. A lot of our weather occurs here in the troposphere, clouds, that kind of thing. Now, the other thing too that makes the troposphere so turbulent is that it doesn't get heated directly from sunlight. It's heated by its contact with the ground. Sunlight warms the ground, that warms the air rises. That gives us the convection that we see. The stratosphere is a little bit different. It's isolated from the troposphere, isolated from the ground. A lot of its heating actually comes from the ozone layer. So ultraviolet radiation, in the ultraviolet B, the B band, is blocked by ozone in the stratosphere. And the concentration in the heating that occurs is greater as you go up in the troposphere. The stratosphere is very stratified, tends to be a very calm layer of the atmosphere, and actually gets warmer as you go up. Whereas the troposphere gets colder as you go up in altitude, as people have experienced driving up into the mountain. Now, the balloons I fly get to about the mid-stratosphere. I've gotten to 124,000 feet, so I've gotten into the upper stratosphere. Typically, I'm about 90,000 feet is kind of a typical altitude for me. Mesosphere and thermosphere, that's rocket stuff. I'm not going to get there. You can't get there with a balloon. We divide the atmosphere up by how it behaves this way. There's other ways we divide it up also. One thing is that the FAA and also the International Aeronautical Civilian Aeronautical Organization, I guess it is. But anyhow, they divide up airspace in the atmosphere, the troposphere, by airspace. And they talk about controlled airspace where you have not controlled airspace. Airspace, controlled airspace tops out at 60,000 feet. Above that, it's not considered controlled airspace anymore. Outer space, the International Aeronautical Federation says that outer space begins at 328,000 feet, which is also 100 kilometers or 62.5 miles. And the reason they select that altitude is that that's the boundary for the Kármán line. And Kármán was the first, or one of the first directors of the Jet Propulsion Laboratory, von Kármán. As you go up in altitude, the air pressure drops, and it's not really air pressure, but air density is what we care about. They track each other really closely. As the air density drops, you have to travel faster to get the correct number of molecules to pass over a wing or an airfoil to develop lift. As you get up higher and higher, that airspeed increases until you get to around 62 miles, 100 kilometers, or 320,000 feet, when the speed an airplane has to travel to remain aloft through aerodynamic lift is 5 miles per second, which is orbital velocity. So you go from an aerodynamic situation to an astrodynamic situation. Above 100 kilometers, an airplane can't develop enough speed to develop lift without actually trying to escape Earth's gravity. You're going to go faster than orbital velocity. So they put that boundary at around 328,000 feet. Near space, in a way, is between around 60,000 feet and 328,000 feet. That would be the region of near space. There's also another nice number in there. That's the Armstrong line that occurs around 63,000 feet. That's another kind of nice lower boundary for it. The Armstrong line, Armstrong was a physician, pilot's physician out at an aeromedical research base in Mexico. And he was looking at air pressure and boiling points of water. And when you get above around 60,000 feet, because the air pressure drops, the temperature that water will boil at also decreases. At around 63,000 feet, the air pressure is so low that liquids at 98.7 degrees would start to boil. And that's body temperature, that's your body temperature, blood temperature, your temperature of your blood. Literally at 63,000 feet, the saliva in your mouth would boil. Your blood would boil if it was exposed to the air. So the Armstrong line is also kind of a nice boundary for the lower part of the of near space. This is what it's like in near space, believe it or not. I've taken pictures to the 1 hour photo lab and got them developed. Twice now, I've had photo technicians ask me if I was an astronaut because people don't return pictures like this, right? You take pictures from the airplane, the sky's blue and you can see the ground and it's all kind of cool, right? But when you see a picture and it shows black space and a blue earth, and you can actually begin to see the curvature, even with the camera that doesn't distort. So don't do a wide angle camera. A camera that does not distort will actually begin to detect the curvature of the earth at around 85,000 feet or so. So your pictures taken from near space show the blackness of space, the curvature of the earth. Not only that, but you're so high, the horizon is depressed. It's called horizontal depression. Around 100,000 feet, the horizon is depressed by 5 degrees. That means from horizon is 190 degrees rather than 180 degrees that we see here at the surface of the earth. Sometimes people have asked me, why is it black in near space? Well, the one thing that's happening is that sunlight will shine through the atmosphere and molecules, primarily oxygen and nitrogen molecules, scatter light. It turns out that the wavelength of blue light is just a perfect match for the size of those molecules. So blue wavelengths of light get scattered preferentially by gas molecules in the atmosphere, whereas infrared, much longer. Since it's a longer wavelength, you don't detect smaller molecules in the atmosphere. The red light shines straight through. You see red sunsets because of that. Blue light from the sun gets scattered in all directions. So no matter where you're looking from the surface of the earth, you're seeing blue light directly from the sun. Now we get up to 100,000 feet or 85,000 feet. air pressure is so low, the vast majority of the atmosphere is below you. That scattering light from the atmosphere is all below you and not above you. So when you're up this high, you're seeing the blackness of space. You're not seeing blue light scattered by the atmosphere. It really does look like this. So what's it like in near space? Well, we get up so high that the air pressure at those altitudes is less than 2% of sea level air pressure. In fact, at 100,000 feet, it's 1%. If you get to about 103,000 feet, it's 0.7 millibars, which is the surface pressure on Mars. If you want to see what the air pressure is like on Mars and test something in a Martian atmosphere, up to 103,000 feet, you'll see what it's like. And we see the temperatures drop down. If you get in higher and higher into the troposphere, it gets colder and colder until you get to that boundary with the stratosphere. That boundary is called the tropopause. By the way, we can see temperatures of minus 60 degrees Fahrenheit or worse. In the wintertime, I've seen minus 90 degrees. That's the temperatures of like a nice day on Mars, and also temperatures in Antarctica. It's just bone-chilling cold up there. Cosmic rays, cosmic ray flux, we are protected from cosmic rays by first off, by the Earth's magnetic, well, actually, go further than that. The solar wind protects us from some cosmic rays, some galactic cosmic rays. And as the solar cycle varies from year to year over the 11-year cycle, we actually see a change in the amount of cosmic rays. The Earth's magnetic field protects us from a lot of cosmic rays, and then it's the atmosphere that protects us from the last bit of them. As those cosmic rays are just diving into the atmosphere, they'll collide with molecules, again, primarily nitrogen and oxygen. They'll shatter those molecules and produce secondary cosmic rays. As they go further and further down into the atmosphere, approaching the surface of the Earth, they get filtered out. They, again, shatter molecules. They lose energy. Eventually, they get absorbed by the atmosphere. So we detect cosmic rays here. It's not that strong. The bodies have evolved mechanisms to handle that radiation. As you go up in altitude, I have measured the cosmic rays with an RM60 a Geiger counter by Aware Electronics. Nice Geiger counter, by the way, for in flight. I don't work for them, I don't get paid for them, but it's a really nice Geiger counter. I've seen the cosmic ray count go from about 8 counts per minute on the ground, about 800 counts at 62,000 feet. That's the Flots line, what they call that, where that maximum occurs. And that's where we get the most intense creation of secondary cosmic rays. Of that, we see far fewer cosmic rays. We're seeing more primary cosmic rays. And on a balloon flight, I just get really amazed when I think about it. Those cosmic rays are subatomic particles that came from another star, perhaps even another galaxy. I'm counting atoms from another star system as I get up into high altitude. My Geiger counter can count each one of those. As you go up in altitude, the distance to the horizon increases. 100,000 feet, in fact, it's over 400 miles away. If you can get into near space, you're looking over 300 miles to the horizon. If a balloon spins around about once per minute, over about 1 minute, it'll see the entire state. Also, since there's no Rayleigh scattering, which is what creates our blue skies, scattering is called Rayleigh scattering. The skies are black up there. You get a high vacuum, 99% vacuum, black skies, curved horizon. You're seeing primary cosmic rays at that point. So in a way, it looks and feels a lot like space. It's nothing like you see at the sea level. So Seattle, nothing like that. How we actually get there was with what we call the near spacecraft, or what I call near spacecraft. Okay, no thunder, no flames, no smoke, no nothing. Very gentle, almost like an elevator ride up. Used to use helium, but now I use hydrogen. It's a lot cheaper. The load line is a string, and it's just a woven woven nylon line you get from a local hardware store. Some balloons will use a cut-down device. I've used them twice, once successfully, and once it cut down the balloon too early. And then the recovery parachute. A spreader ring keeps the parachute from getting twisted. Some tracking modules, and this is APRS, the GPS design. Oh, by the way, the GPS has to work at high altitude. Some GPS stop working at like 30,000 feet or something, or 60,000 feet. So make sure you get a GPS that will work in near space. And then your experiment. so balloon sats and things like that. Some people will fly a recovery aid. This can be a backup beacon for DFing. It could be an audio beacon, it could be a strobe. So if it's landing at night, you want that nice strobe. It is really helpful. If you land out in a cornfield, an audio beacon is really helpful because you can't see more than one row over. And you can, I mean, I've almost walked right past a balloon sat, or my balloon that was like one corn row over, and it's like, you can't see the thing, right? So you're looking for, oh, by the way, you want a brake parachute also. Do not use a camouflage parachute. That's not helpful. The whole weight for the payload is 12 pounds. The height of this beast, this is a big beast, about 40 feet tall from top to bottom. It's a pretty tall beast. Climb rate averages around 1,000 feet per minute. I pushed it up to about 1,500 feet per minute on some flights. And max altitude, in some cases, better than 100,000 feet. 125,000 feet is the boundary just to almost got to. In fact, I may have made it. My GPS transmits once a minute. I may have gotten there, but didn't transmit at altitude at that time. So that's kind of what it takes to get to near space. And it is, like I said, $150 for consumable price for your consumable costs. The rest of it, though, can be as much as you want it or as cheap as you want it. The nice thing is, even if you fly a $150 Geiger counter, you get it back and you get to fly it over and over again. So, and on board for tracking, we'll use a GPS, a TNC, and a transmitter. And there are now complete systems you can buy that do that all for you. And Bill Brown has got some stuff like that. Great stuff. In the past, when I started doing this, you had to build it all yourself, right? And nowadays, we've got people producing onboard tracking equipment that works just perfectly. On the ground, use the Eclipse system, and which is really nice. If you transmit at 144.390, then people can use eye gates. And we're flying for students who do not have an amateur radio. Well, they can use a website like Find You or APR's website, and actually turn on their cell phone, get a Google map, and it shows the position of the balloon. You can click on the icon, they can see the altitude, speed, direction, some conditions on the flight, and they can actually track it like mission control would track an old mission, like a Mercury or Gemini mission. So the students even more involved. Okay, so that's what it takes to get there, and this is one of the most amazing flights I did. Is August 21st. It was the day before school started, and I was really afraid, I got to get this launch done, get everything recovered, and I got to be ready for school the next day, and it worked out, thank goodness. This is going to be April of 2024. This is going to happen again. With any luck, I'm going to be retired, and I'm going to have the whole week off instead of just one day to do a balloon flight. So we'll talk a little bit about what actually happened with the flight during the eclipse. So this is what I launched, and we actually went to an airport in Oregon. Where I'm at in Idaho, southwest Idaho, we had 99% fatality. And I'll tell you, 99.5%, 99.9% fatality is not fatality. I don't care how many nines you put there. If you're not at 100% totality, you are not going to experience the eclipse. So I had to drive about 40 minutes to a town called Ontario in Oregon, and they have an airport. It's a small airport. Went there to do the balloon launch, and they had about 90 seconds of totality. Everybody in Idaho is going further north into seeing the eclipse. This is only a 40-minute drive from my house, so let's say I'm going to go do this. It may not be quite as long of a totality, but I need to spend my time facing this balloon, so it's fine. I can see 90 seconds of totality, and I'm out of here. This was my near spacecraft. In the back, you'll see the hydrogen tank, and we've got all the tracking modules and all my balloon sets, all my experiments all laid out here. We lay this on a bed sheet to keep dirt, rocks, and things like that off. We kind of keep things clean. Also, it's easier to see the stuff is there, and you're less likely to step on things because it doesn't get hidden in the rocks or something like that. And here's where we're doing the launch. This is done at an airport. So we had a bunch of pilots who had flown in, watched the eclipse, and they're flying out. They didn't have to worry about the traffic at all. In fact, it turns out traffic wasn't too bad in Ontario, Oregon. The nice thing, though, is we did have some kids who were there. And when you're doing a balloon launch, they love to get involved. So they were helping us launch this balloon. We're raising it up the balloon, followed by the parachute, tracking modules, the experiments. Kids are holding this down. They're getting ready to release it. They're going to do the countdown for us. And these are pilots, seeing a weather balloon. The crowd was great. Loved it. The kids loved it. It was just a wonderful event to do with these folks. This was Rachel, who was watching the eclipse, and she's watching it the way you should watch it, with safe eye protection. So she's watching the eclipse here. This is during the partial phase. It hasn't reached totality yet. And this is, finally, we had some totality, so I got a couple pictures with the camera. Digital cameras, 6-power optical zoom. I didn't do a digital zoom on it. I got the corona on the left side, and the diamond ring effect was on the right side. They called it the diamond ring effect. This was the flight I did, and we did the launch. And it was KD4DTH-7 was my primary call sign. But you'll see as we went up, we initially went to the west a little ways for a few thousand feet, and then we got on into a jet, well, not jet stream, but winds that actually carried us more to the southwest. So we started going east and then off to the southwest. At high altitude, we made a turn and went back to the east again, and the wind speeds decreased because you'll see the dots get closer together. So our airspeed is lower. We're transmitting once a minute. Each of those dots is 1 minute. We slowed down as we got to high altitude. To get around 60,000 feet, I can see where winds can change directions and wind speeds can slow down. Now, if you hit the jet stream, bets are off. It works a little bit differently. But at really high altitudes above 60,000 feet or so, I start noticing that's where I kind of typically see some slowdowns and some changing in direction. And we did the burst and came down. Flight got data most of the way down, position data most of the way down. This is the three-dimensional image I put together using Google Earth. And can I just say now, if this is just an image, but under the KLM file, you can actually rotate this around and see how that flight worked. But it's kind of what the image looked like if you were to the south watching the balloon go up. Kind of get that funny, kind of almost a figure 8 shape out of it. One thing I measured was cosmic ray flux. I talked about, cosmic rays get really intense at 62,000 feet. Well, they did here. The totality happened around 50,000 feet, as I recall. A little of a blip in the data, but you know what? No matter where you look, you'll see blips in the data. Cosmic rays are fairly random. With just one Geiger counter, what I learned is don't send up one Geiger counter. Cosmic rays are too random. I can't see or pull any data out of here to see if there was a change in cosmic rays because of the moon blocking the sun. Not that I expected there to be, because even cosmic rays that are emitted by the sun, and there are solar cosmic rays, are going to be deflected by the Earth's magnetic field. So it's possible that even if the moon does block some cosmic rays from the sun, by the time the cosmic rays get to the Earth, their paths are going to be distorted by the Earth's magnetic field, and they'll still get in and get around. So in 2024, I'm going to do this again, but I'm going to have probably like 3 Geiger counters. I'm going to watch the data from all 3 of them simultaneously and kind of get an average for them, see if I see some kind of a drop. Also send up photometers, and these are light sensors. These light sensors I use are based on LEDs. People are familiar with LEDs emitting particular colors of light depending on how they're doped. So red LED, produces red light. It's not based on the plastic, the color of the plastic. It's actually based on the way they dope the silicon chip inside the LED. An LED works a lot like a solar cell, and also a photodiode. They're the same thing. If you shine light with a proper energy on an LED, you can actually produce enough energy to go across the band gap and produce a current. You can convert photon into current, into the movement of electrons. And by using an operational amplifier that's set up as a transimpedance amplifier, you can convert that current into a voltage, and then microcontrollers can digitize that voltage. So the more intense the light, the greater the current that the LED produces. The LED only produces a current based on the color of the photon the LED is designed to emit. So red LED typically only detects red photons of light. Now, there's some slop in there. You can use these LEDs, and especially with their plastic covers, detect intensity of different colors of light. Here I had an 890 nanometer, excuse me, not millimeter, nanometer infrared LED, pointed it up, and then hooked up to the transimpedance amplifier. And this was the intensity of sunlight in the near infrared, 890 millimeters. And you'll see around 45,000 feet, the color of the sky went to pure black. That's where the totality passed over the balloon. So we're looking at sunlight decreasing as we go up in altitude, the eclipse ends, and the intensity goes back up again. The reason you get all that jagginess in the data is that the balloon is spinning and tipping and tilting back and forth. So the LEDs are very sensitive to their pointing direction. So we're looking at different parts of the sky, closer to the sun, further away from the sun. So we get a lot of that swinging back and forth. We get a lot of variation in the data. The average shows it dropping down to 0 time of totality. So around 44,000 feet is where the moon shadow passed over my balloon. Green light, same thing. Ultraviolet, same thing. All of the colors of light showed that decrease at around 44,000, drop off to around 44,000 feet during totality. And we were in totality for about a minute and a half, a minute. We were a little bit further south, so maybe a minute. So over about a 1,000 foot span, change in altitude, we saw the light, the skies go, pretty much pitch black. We're seeing that no matter what color we're looking at. And I was wondering if we would see maybe different colors would fade out first, but looking at this data, it looks like that's not the case. The colors all faded out at about the same rate at about the same time. External temperatures. Now I'm thinking, the moon shadow is going to pass over us. We're not getting exposed directly to sunlight. We're in the stratosphere. It's warmed up by its exposure to the sun. Maybe we'd see some differences there. I wasn't really in the stratosphere when this occurred. During the eclipse, we were still below the stratosphere. Well, the balloon was still below the stratosphere. So I didn't really see a change in the air temperature that I don't normally expect. The air temperature drops as you go up in altitude, reach the tropopause, the boundary between the stratosphere and the troposphere, and the temperature starts going back up again. And that's what I see. I don't see any particular changes just due to the eclipse. Changes we see occurred, the changes should naturally occur. So the lesson I learned here is launch several balloons, send them maybe 10,000 feet apart from each other, collect the same data, and sample the air temperature at different altitudes to see if you see an effect. So even if the results aren't what I expect, I learned something, and that's also important. This is pictures of totality in near infrared. Now I take cameras, or usually now I just buy them, with the hot mirror removed, the infrared blocking filter removed, and then I'll put up 2 color filters in front of the lens. I use a theater gel. They're theater gels, blue and red. Theater gels are designed to project, colored light on the stage. The stage lights are incredibly hot. And if the theater gel blocked infrared, the theater gels would melt or even catch on fire. And that's not good for your stage play, for happening on the stage. So theater gels are designed to transmit infrared, and then along with the color that they're dyed for. If I take a red and blue theater gel, they'll transmit near infrared. And this is just beyond red into the infrared. So we're looking just into the infrared where we can't see. Red and blue are complementary colors. So the red will emit red but block blue. The blue will emit blue but block red. So that together they block visible light from reaching the camera, the camera lens and the CCD imager. The only thing that gets into the camera is near infrared. This is a picture of the horizon in near infrared as the balloon's going up. If you look in the center of the horizon, you will see you'll see this dark spot out here. This is the moon shadow. The moon shadow is approaching the balloon from over the horizon. The moon shadow is traveling something like 1,000 miles per hour, and it's coming up over the horizon. One way you know this is near infrared is that even at 40,000 feet, the sky is still blue. But in infrared does not get scattered by the atmosphere very strongly. It takes a lot of atmosphere, hundreds of miles, to scatter infrared light. So the horizon, the very edge of the Earth's horizon, will be light in infrared because you're scattering some of that light over hundreds of miles. Overhead, you're looking at only miles or tens of miles or something like that. So the sky is very dark near infrared. But we do see the shadow, and the shadow is direct on the surface of the Earth. We are not detecting the shadow in the atmosphere. We're actually detecting the shadow on the ground because there's not enough air above the ground to scatter the infrared light. So that infrared light reaches directly to the surface of the Earth. So this is moon shadow directly on the Earth that's approaching. Okay, now I can't control the pointing direction of the camera. So what I'd learned also is put multiple cameras on the balloon. Don't fly just one. So on the right side, you see the moon shadow. It's come over the edge of the Earth. And we actually see this round disk on the surface that gets darker towards the center. You can see beyond the moon shadow, you can see the horizon, the edge of the Earth is still illuminated. This is one of the best shots I got of the moon shadow. And I'll have to explain a couple things here. That round disk is only some 10 or so, 10, 20 miles across, something like that, 30 miles across, something like that. We're looking at the shadow of the moon directly on the surface of the Earth. And you'll notice it gets dark to the center and it kind of fades and kind of gets edgy and kind of fades out on the edges. A couple of things to notice about this one. There's a lake, and that lake down there is black. Lake is black because water does not scatter infrared light either. Unless the sunlight reflects off of it like a mirror, you get lakes are black. They're reflecting the black sky above, not direct sunlight. Sunlight directly from the sun. So unless the sun lines up just perfectly with the lake, you get no reflection of infrared off of a lake. Also notice that it's white. You see some white patches down there. That's chlorophyll. Now the eclipse is happening, so the ground is darker. In the daytime, if there's no eclipse, we would get a much brighter image, but it's becoming nighttime as this eclipse is passing over it. Chlorophyll, healthy chlorophyll, absorbs red and blue light. It reflects green that we see, but also reflects infrared. So healthy chlorophyll, plants with healthy chlorophyll are very bright white in near infrared images. Now, this is a black and white image. If I had made this a color image, we'd see different colors. The colors get thrown off, and it doesn't make a lot of sense for eyes to see red as infrared. So I do this as a black and white image. We're looking down in Idaho, and we're seeing valleys where they are farming. Outside the valleys, it's hilly, it's deserty, it's outside away from the rivers, and no one farms those. So we see these darker gray patches are scrubland, they're desert, rocky, sagebrush, that kind of thing. Where we have valleys and they're irrigating, you can actually see white patches from healthy chlorophyll, from the chlorophyll in healthy plant. This is when the shadow actually passed over the balloon. So we are in the we're in the moon shadow. Horizon is brightly illuminated, but we're inside of this round disk some 30 miles or so across. It is the moon shadow on the surface of the Earth. And that's like one of the most interesting pictures I think taken. And this is the moon shadow as it's now moving away from us. So this is looking to the east. The moon has left. It's on its way out. The sun is at a low elevation, so we're seeing glare from the sun as it's shining out from the edge of the moon. But we got a little bit of glare there from the sunlight. But we do see that disk of the moon shadow moving away. Again, moving at something like 1,000 miles per hour. So this is, literally, a minute or two, and the shadow just races past the balloon. Took an image in thermal infrared also. So thermal imager, I pointed at the horizon, and this is a typical example of a picture I returned. Did not coordinate a thermal imager to take pictures with the visible camera or the infrared camera, unfortunately. So I can't correlate, when one was taken. All infrared pictures look similar to this. There's no difference. So the horizon, at least the horizon in thermal infrared, looks identical whether there's an eclipse or not. I think that's trying to tell me that the moon shadow doesn't cool the atmosphere substantially as it passes over, so we're not really seeing a difference here. We do see that above the horizon, it's minus 80 degrees. It's very cold up there, and the thermal imager is telling us that. But the view doesn't look anything really different. So I'm seeing, a warm ground that's yellow, an atmosphere that's not quite as warm, that's kind of reddish. something out there. It could be a plume, exhaust smoke, a lake or something out there that's creating that dot out there. And then above that, it is just bitterly cold, minus 80 degrees. Recovery, it took a while to find the recovery site because the balloon got down low enough that we couldn't get direct signal from it. Also, we were out of range of APRS. So I had to go home, drop off my wife so she could go to school, then check the APRS website, and it gave me a position of the balloon only 1,000 feet above the ground. That's great. I'm going to go find it. Drove out to where the balloon's at, and as I got close, I picked signals from the balloon on the ground. I stopped my car, looked out, and this is what I saw. It was a mountain about 700 feet tall, and the balloon was about 700 feet away, and it's about a 45-degree slope to get up there. So it's like, I got to go to school tomorrow. I got to get up as quick as I can. So I hustled. I got some exercise, got up there to go recover my balloon and my near spacecraft, and got it all down and got all my data. This was one of the rougher but a short recovery that we have in Idaho because, like I said, we are the most mountainous state of the over 48 states. There's nothing more mountainous. Colorado has taller mountains. Colorado is not as covered with square mile of mountains as we have in Idaho. I did manage to do the recovery and managed to go to work the next day, no problem. No worse for wear. So it was a rather interesting recovery. And that is what I have. So let me go ahead and stop my presenting. And let's see. Let's see, where do I actually stop? Where do I go to stop that? Oh, okay, stop share. I think we did. Okay, there we go. I think we're back again. So anyhow, that's introduction to near space. Now this is high altitude balloon stuff. If you want to be, you're a frustrated astronaut, this is what you do. This is the results we got from the Eclipse flight.
Well, great. One of the questions that I had was, you have a lot of, equipment and storage and different things that are flying here that you have to go recover, I guess. And have you lost many of these, or do they actually fall into a place where you just can't find them, and do people mail them back to you? Tell us about that.
So I never lose anything.
Yeah.
Of 200 flights, I've lost 2. One of them stopped transmitting at 30,000 feet. Probably made around 90,000, so it had a long ways to go up before it burst, and it's difficult to predict what the flight will look like. The second one, we knew where it landed. We didn't go get it right away. We went to go chase some other balloons first. Came back, and it landed literally on a main road south of town, a town called Kuna, Idaho. We suspect that someone saw it land because there's a lot of traffic. They took it home. There's 2 phone numbers on it who to contact, and they didn't bother to contact. So I'm going to put that down as a stolen flight.
Mm-hmm. Well, that's really interesting.
If you do redundant tracking, so 2 transmitters, 2 GPSs, 2 of everything, successful flights, and just kind of watch where you launch and where you land, so you don't land in someone's backyard. Pretty much I get them back.
So what's the average distance? I mean, it's going to go up, it's going to burst, and it's going to come down, but it's going to travel a certain number of miles, I guess. Is there any average distance that you might have to travel on these?
So one issue is, do we pass through the jet stream? And I've passed it on my first flight. I passed through the jet stream. We went 160 miles. Wow. Another one, I launched in a high pressure system in Kansas, and high pressure systems, you tend to have light and disorganized winds. We landed about 4.5 miles away. Mm-hmm. We could have walked to go pick that one up. An average, though, I'd say 40 to 60, so maybe 50 miles, give or take. It's kind of a flight.
Hey, Tom.
Yeah.
I wanted to tell you that one of my flights landed in a swamp. And when we went to recover it, the local said, yeah, be a little careful. There's a lot of alligators in there. And we realized that the cost of the payload was not worth it. So we let that one go. Yeah. I had another one that you were talking about downrange. I did a high school down near Birmingham and Alabama. And so I weighed everything carefully and filled the balloon to the correct lift. And when my back was turned, a student showed up with a 2-pound payload and hooked it onto the flight train. And when we let it go, it just barely got off the ground. I said, I had plenty of lift. What's going on? And it was going up about 100 feet a minute. It stayed up for 7 hours and ended up 700 miles east. And it was 100 miles east of Jacksonville, Florida. And this is not a good thing, because what's 100 miles east of Jacksonville, Florida?
Mm-hmm.
Water.
Yeah.
Atlantic Ocean, the Bermuda Triangle. So it ended up in the Bermuda Triangle.
Oh, yeah. Well, I know there's some places you can't get to them, so, but it sounds like you've had pretty good success rates.
Now, my very first flight in 1987, 33 years ago, the batteries died before it hit the ground, and we had a single TV transmitter and a single beacon. No GPS existed back then, so we relied solely on direction finding techniques. And we came within a mile of where it actually landed, but we never did recover it until about 2 months later. A farmer found it while he was harvesting his soybeans and called us, and we got it back, and it still operated. I put new batteries in it, and it still worked after sitting in a field for 2 months. And we were within probably a quarter mile of it. We drove right by that farm, but in the soybeans, you would have never, ever seen it. So that's why Paul indicated have beacons going off of light, have sound beacons beeping. Those really help. We landed once in a cornfield, and in fact, I was flying with Paul at the time. We were in a cornfield and walking up and down the aisles of corn, rows of corn. You just couldn't see it until you were right on top of it. We did one that had a TV camera. I had a little TV set carried with me, and I could see the roots of a corn stalk. And all of a sudden, I saw a tennis shoe, and I said, "Whoever's got the red tennis shoe, stop right now."
Yeah, yeah. Oh, yeah.
They didn't see it until I told them to look left towards the camera, and there it was. They could not see it one row away. So cornfields are particularly nasty in that regards.
I was going to say, you might want to add a drone to your search routine. Get up above the corn stalks and look from the above.
It's not. Oh, go ahead, Paul.
Yeah, I've done that. I've flown a drone with a Argent digipeater, sent it up. Now, I not use it for a real flight, but I did a test, and I was a mile away from my house, and I got packets from the balloon. I couldn't get them directly from the ground. I could get a repeat from the drone. So that should work. That should work.
And that's Argent Data, right?
That's right. Yes, right. Yeah, Argent Data. That's right.
They have a digipeater module. They have a lot of neat stuff for APRS tracking and balloon tracking as well. One thing I also try to do is put a Find Me Spot unit on it. It doesn't give you good flight data, but it will transmit to the Global Star Network from the ground. It's used for hiking and vehicle tracking. And I also have an Iridium modem, which you can get full flight data on, and that transmits from the ground. So we actually had one that was picked up by a fellow, and we noticed it was in a house, and we knocked on their door.
Well, yeah, you can't always recover it, Bill, as you know. And I mean, here's our last flight that went down in the Philippines.
We did one. It landed. It was in Kansas. We got the position. As we got closer, suddenly started moving again. It turns out the landowner landed right behind him in a tree. Thank goodness we didn't hit him. He picked up and was taken to the sheriff's office. We got to the house, and his wife called and said, "Back home. They're here to pick up the balloon."
You know, that's the thing I'm a little worried about nowadays. I mean, back when I grew up, people didn't sue you for everything. Nowadays they do, and I worry about these things falling on somebody's head and poking them in the eye, or who knows, man.
Yeah. But the goal is to, when you do your flight prediction, look at where it's going to land, and don't land in town. Land outside of town, farm fields or something like that, and you're pretty good.
Yeah.
When people are spread out far enough, you're just not going to hit people. The same way you don't hit airplanes on the way up. Spacing between airplanes is too great. Yeah, if you land in town, you're asking for trouble. Don't. In fact, I would even look at the descent. The descent going to pass over town. If it's going to pass over town near the end of the descent, I'd probably move my launch site just in case it lands early. You just want to stay outside of town.
Well, there are about, I was studying up on some of these launches. So I think there are about 1,000 weather balloons that are launched a day, I guess, around the world. Not in the U.S., but around the world. And
about 200 every 24 hours in the United States, about 200 of them.
Yeah. And so I've got a friend that's been on the show with me a while. He flies in a wide body, an Airbus. And 35 years, he has never seen a balloon in the air, flying in 35 years. Now, he's seen a hot air balloon, but he's never seen a weather balloon or any other balloon, So that just shows you it's a big open space up there.
So yeah, they call it the big sky theory.
Yeah.
What the FAA says, and you're just not going to. And also, we designed the payload, so even if they hit an airplane, styrofoam, plastic, things are not going to be bringing down an airplane anyways. But you finally note them. The pilots know that we're going to launch from this place at this time at this heading. They have an idea to kind of keep an eye open just in case.
As far as I know, over the 60 plus years of massive radiosonde launches for the Weather Service, they've never hit a plane. They've landed on buildings and property. As far as amateur radio balloons, there's only one that I'm aware of that actually hit a car, and that was one of Pete Sias's. And he did have to repair the guy's windshield, but the guy was very good about it. So we actually tried to catch one in the back of a pickup truck once, and it actually bounced off the side of the truck, so we almost caught it in the truck. And I believe, Paul, did you not actually catch one before it hit the ground?
So two different occasions. So one, we did the chase. This is October of '98, and it was a friend of mine who actually jumped out of the car and ran into the field and caught it as it came down. And Art Connor jumped out of his car to take a picture of it. And then about 6 years later, one came down while I was living in Idaho. That I ran after it and I missed it by a yard. I was in a plowed field. I couldn't turn quickly enough without falling or twisting or something like that. And I'm thinking, in the movies, they run and they dive and they catch it. I'm not going to do that. Not in real life. You don't do that. But yeah, I missed one. Just like, oh my, I almost got it.
I came within about 20 feet once, but I keep trying.
A lot of them, if you do it right, and if you don't hit a jet stream, you can be in the area. I've seen lots of balloons come down. Parachute at that point, see parachutes come down, no problem.
Now, the Arizona Near Space Group, they had a payload that calculated the winds aloft on their Arduino chipset they had in their tracker, and they calculated the descent rate and sent down another packet. In addition to the actual position, they sent down a prediction packet, and all you had to do, and it was a big red X on the map, on the APRS maps, and all you had to do was follow the red X, and it would land right in front of you. And so there's a good Arduino project for you, Glenn.
The other thing too is, these balloons you can see, even 100,000 feet, you can see them. If you know where to look and the sky's clear, look up and there's a little faint star in the sky. That's the balloon. You can actually watch it in 100,000 feet.
Yeah, we put a telescope on one and we could actually see the thing burst and go into 100 shattered pieces. It was pretty awesome. That particular one actually landed in O'Hare International next to the jet runway. And when they went out after it, they convinced the ground crew to carry them off across the runways to go after the payload because they knew where it was sitting. And they did alert O'Hare International and tell them that their payload was coming in towards the airport. So O'Hare was okay with it, and there was no issues. But when the ground crew spotted the payload across the other side of the main jet runway, it was the thrill of the chase, and they charged right across to get it because they got excited. But what they failed to realize that there was a 747 landing, and they went right in front of the jet. And so the jet landed, they put the payload into the vehicle, drove them back to the gate, and said, "Guys, if I were you, I would head home quickly. We're going for a very long coffee break," and try and hide.
Yes. So one of the things too, when you bring kids with you, you've launched their experiments. They've been there. They've seen the balloon fill. They've seen it take off. They've been there on the chase. They've tracked. When it's time to come down, you have to watch them because they will take out of the car and run across the street to go chase this thing on the ground. You need to be, whoa, hold off. Look for traffic first, please. Okay, now let's go get it. And here, I'm an adult, and these kids are running way ahead of me, and it's like, slow down. I can't keep up with you. But they get so excited to get their payloads back.
All right, guys.
I've got a screen I'd like to share with you about the Eclipse. If I can, if you'd like, I can bring that up.
Go ahead.
I can find it. There we go. Take a second. There it is. Share. And I'll try and make it full screen here. Yeah. Try to make it full screen.
Isn't technology wonderful?
Okay. It'll probably start at the beginning of my entire PowerPoint, but we were in Clarksville, Tennessee when Paul was over in Oregon. And what I wanted to, oh, there we go. Oh, geez. I wish there was a way I could go directly to that slide. So you're going to see the Cliff Notes version of my balloon talk. Come on. Oh, that's a neat picture. And that's one of your payloads when we shared a flight in St. Louis at the Great Plains Super Launch 2015. That was a picture of our weather balloon with Paul's payload and my payload, as photographed by another balloon that had a camera on board from about 200 feet away. This is at 53,000 feet. You can still see that blue haze as the atmosphere, and the blackness of space is just beginning to show up at the top. And you can see the balloon is expanded and is getting a little translucent, and it starts out about 8 foot in diameter in the ground, and it'll be about 30 feet when it pops in the upper at the stratosphere. So this is about halfway expanded.
But for a sense of scale, that orange payload I was told is 1 foot across.
Yeah, so it's a pretty good sized balloon at this point. If the government had tried to take this photograph, it would be a multi-million-dollar project, and they would likely would have failed on their first attempt. So just these two were matched perfectly with the lift. In fact, they almost tangled up. I think they did for a second.
I think they did, yeah. I think so.
They tangled up and then unwound as they lifted off, as we launched 10 balloons at the same time. And these two just stayed perfectly in sync throughout the flight. And I think they landed maybe a few hundred feet from each other. So this one landed in the front yard of a nice front yard. It was real easy to get. And I think the other one landed on the guys near the front porch of another house. So, I think the other one landed in a tree near an airport that you had to saw the tree down.
That's right, St. Louis Airport. It was an abandoned community, subdivision or something like that, abandoned. So there were trees, no homes, so no one cared if we cut down the tree.
And from that point on, you carried a chainsaw with you to all the remaining super launches, as I recall.
I've got a saw. I haven't done the chainsaw lately, but I carry a saw with me. Yep.
So this is what the Great Plains Super Launch looks like. We launch upwards of 10 latex balloons and a few of the pico balloons, and that's 7 balloons at once. Kind of looks like the constellation Orion. And these are the pico balloons we launched. This is what we did in Texas. And that's what it looks like on the tracking maps. So I wanted to show you, however, what we did for the Eclipse in Clarksville. The totality path is on the left. And that map on the right shows about 100 amateur radio balloons flying at once across the path of the totality. And from my location, there were at least 20 APRS balloons up at the same time within radio range of my ground station. And 144.39 was a solid carrier. It was just that solid. Fortunately, I also transmit on 144.34, and I had a clear channel to receive my balloon, but it was just unbelievable. But that you can actually track the path of totality, all the balloons on the right there. And we launched 3 pico balloons as part of that, and they showed up. They stayed in sync several days later out over the ocean. But I wanted to show you that, Paul, because that was a pretty neat.
That's good. Yeah.
Neat map. And let's see. There's one other thing I wanted to share. Let's see here. Okay, if I can find it. Here we go.
You're doing that. Okay. When you're done, I'll see this when you're done. Yeah.
This is 1992, and I put Pete Sias's ham shack that we mentioned that you saw your first balloon at, and probably right around 1990 to 91, somewhere in there is where he was flying. And this is his ham shack. He converted his old house on top of a hill in Kansas, Salina, Kansas, converted the whole house into a ham shack with. Now he's got hundreds of antennas on about 20 towers. This is in the early days. And that dish is James Van Allen's original dish antenna that they used to study the Van Allen radiation belts. And he got that dish from, I believe, University of Iowa, and had to haul that on a semi-truck back. That's a battleship gun mount that steers the antenna. So.
Yeah, my understanding is his wife got upset with all the radio equipment inside the house, so he built her a new house, the old one.
Yes. Now, I stayed in this house once when I was visiting. We were doing a balloon flight together, and a storm was brewing on the horizon, and all of a sudden I heard a lot of arcing sounds coming from the coax, because he would unhook the coax if there were any possibility of storms, and all the coax ends were zapping. I could see them in the dark, arcing, and he showed up, and the thunderstorm was getting kind of close, and he all of a sudden his truck shows up and he says, "Bill, if I were you, come on down to the house, the main house. You don't want to be up here during a storm."
Yeah, you know, there's a dish just like that here in Collierville. I think the guy's name was Paul Wilson. He was big into EME and so forth. He had a dish just about that same size. In fact, it's still up at the house, and it's on a gun turret to turn it there. Hey guys, we need to move on. We're running a little late here, and Paul, stick around with us if you want to. We may touch back on some of these subjects here in just a couple minutes.
Okay.
And I've got just a couple other things to mention here. But we appreciate you coming out tonight, and
My pleasure.
thanks, man, for the presentation. And it gives us a different perspective over the little balloons that we're flying, you know. Everybody kept wanting to know, put a camera on it, put a camera on it. Well, we can't. We can't fly cameras. They're too heavy. But they asked for it, and there it is right there. So you had some cool pictures tonight, and I think that's what they were wanting to see. Thank you so much for coming out and being with us tonight.
Thank you.
And stick around if you want to, and we'll be back in just a second here. Ham for the holidays. ICOM's new ID52A and the IC705 give hours of fun and enjoyment working your favorite bands this holiday season. ICOM's newest handheld amateur radio is the ID52A. Larger radio, larger color display, and a louder audio. This VHF-UHF digital receiver is much more than a replacement for the ID51A. It's also a new way of communicating. The multifunction D-band D-Star transceiver supports DR mode for easy access to local repeaters based on internal GPS information. The ID52A also has Bluetooth for audio and data control. And for the first time in the amateur radio industry, you can now send photos from a connected Android device. Other features include wideband receiver with guaranteed range of 144 to 148 and 440 to 450 megahertz, integrated GPS including grid square location, a micro USB for data transfer, programming, and charge, and it's IPX7 waterproof. The ID52A is a perfect companion to the IC705. Both use compatible batteries and headsets. And you can also use the same Android app for D-Star operation. The IC705 is a perfect sidekick for hams that like to enjoy both the indoors and outdoors. It's the perfect QRP companion and covers HF 6 meters, 2 meters, and 70 centimeters. This compact rig weighs in at about just 2 pounds. It has a 4.3-inch touch screen with live band scope and waterfall, and you get 5 watts with the BP272, and you get 10 watts with the 13.8 volt DC. Has a micro USB connector, Bluetooth, and WLAN, integrated GPS with antenna and GPS logger, and it comes with a speaker microphone standard. The perfect accessory for the IC705 is the optional LC192 backpack. It has a special compartment for all of your accessories. Visit www.icomamerica.com/amateur for more information on ICOM radios.
LDG Electronics provides state-of-the-art antenna tuners for every amateur need. From QRP to QRO, fixed stations, portable and remote, an LDG tuner will match your radio to your antenna using our lightning-fast, proprietary tuning algorithms. LDG is a family-owned and operated company dedicated to bringing innovative, quality products to the amateur market. All LDG products carry a full 2-year warranty that is fully transferable. Support is only a phone call or email away. We're always here to help you. Visit us on the web at ldgelectronics.com.
All right, and we're back, and during that, I heard somebody mention nuts and bolts. Look at there. Going to mention one of the little articles they had in here this month. We'll talk about that later. Hey, back, Paul, I think Paul wanted to mention something else that he did. Paul, you want to continue there for a second or two?
Sure. I'm Dr. Paul. I don't go by that, but I have a PhD. And to get a PhD, I had to do original research. Now, my PhD is in education, so I studied science education. I actually looked at the effects of a BalloonSat program on student attitude towards science. I actually designed kits. I don't sell them anymore, but for about 10 years, I sold kits. I actually had students solder these kits together. They used a pickaxe as the microcontroller because it has a built-in A to D converter. They could build one of 3 different sensors. They would build the airframe for their BalloonSat, so it's a model satellite. We would launch them for them. And launching these satellites and then measuring student attitude towards science with an instrument called ASRA. They measured what they thought about science before, what they thought about science afterward. I found in my study that there was a 3% increase in student attitude towards science as a hobby activity. There was no gender effect, so both boys and girls were more positive or more interested in doing science as a hobby. So, like you like rock collecting or telescope out, that kind of a science hobby. The benefit of that, or the kind of the strength of that, is that if students have an interest in science as a hobby, they're more willing to take science in school. If you're more willing to take science in school, you're more willing to work harder at it. You're more likely to be successful. And when students are successful, they're more willing to carry on and do it again and do more science. The idea is if we find projects like this that involve balloons, amateur radio, any kind of science activity, but amateur radio, balloons, and that kind of thing, we can increase student attitude towards science, so they're more interested in taking science in school and being more successful. That means we have more students who can graduate with STEM-related degrees. Mm-hmm. So it's another way to maybe help improve our competitiveness in the United States, because if you think about it, the top 1/3 smartest students in China, the same number as all of our students in the United States. There's a lot of people out there that we have to compete against, and we really want a strong STEM background for our students.
Yeah. All right. Well, thank you, Paul, for that. And hey, we got a video that just came in from space here. Let me see if I can get this on here. Let's see.
Yeah, all black. That's pretty much space.
There we go. There we go. Well, we're back. That just came in. Now, Paul probably doesn't know what's going on here, and probably some of our viewers don't know about the ants. One of our previous flights on one of our pico balloons, someone asked us, how do we steer it? How do we steer the balloon? And we said, well, we came up with the fact that we had trained ants on board, and they had trained for a year and went through a real rigorous process of training. So anyway, the ants became very famous, and most people in our Facebook group that are following our flights now, they keep referring to and want to know where the ants are, how the ants are doing, and so forth, and making comments about it. So it put a little life into some of our launches here. But that was Huey and Dewey there. We started off with Huey, Dewey, and Louie. Louie didn't make this flight, but anyway, I want to just give everybody an update here. Bill mentioned it a little earlier on where we were, and let's see. Bill, it looks like we are doing a much straighter flight. Let's see. I mean, if you look at the flight here, it's pretty much been pretty straight. No, detours. We didn't go to the Arctic this time, the North Pole. We didn't go in circles. So it's been pretty good. And Bill, what do you think? We're going to make it to Memphis by Friday, maybe?
I think so. You're slowing down a little bit. You're down around 30 or 40 knots, but I think you're still on a nice track to make the completion in about 2 days.
Well, let's see. We launched. Let's see. We launched. Well, there we go. We launched 7 days ago. 7 days and 12 hours ago.
That's pretty fast to make it back to the West Coast in 7 days.
Yeah. So we're, I think we're doing pretty good. We'll find out. Looks like our altitude is still good at 44,000. We're, like you say, we slowed down 35 miles an hour. We were booking quite fast for a while, but so far we're happy with the flight. And
Just north
this
of
will
Hawaii
be
now.
hopefully this will complete lap 1. And we're trying to beat our 3 laps of a previous flight. Don't know if we're going to be able to or not, but and I can tell you. And how does this compare to your high altitude balloons? Do y'all launch more in the months where the weather is not as bad? You know, like right now we're in the winter time. All of the big storms are south of the equator. How does that affect the high altitude stuff?
So typically, if we have high pressure, regardless of the year or the time of the year, if we have high pressure, we tend not to go very far.
Yeah.
Winter time, though, I think we tend to have the jet stream kind of below, south of us, which carries cold air from Canada, so we get these really cold blasts.
Yeah.
So when that happens, launch. Stay away from your space if you can.
Well, and I guess you can launch.
The jet
You
stream
can
is a
launch.
problem.
Yeah, I guess a little moisture doesn't hurt you. Do you have to have perfectly clear weather when you launch?
No. The issue is the winds are going to blow the balloon, so you're going to go a lot further. Instead of tens of miles, you might go over 100 miles. And quite frankly, I'd rather stay indoors when it's that cold.
Well, and we learned, and people told us, and we learned, even the hard way, once or twice, we can't launch a pico balloon through a cloud that's got water in it up here. It just, it's going to come down. Yeah. So I think 12 drops of water is probably more than a balloon will lift. So it comes down, and but I guess your balloons are so big they'll just go right up through it. They'll go right up through it, won't it?
Yeah, it won't be a problem. Enough positive lift, that's not a problem. It's just a question. And I've launched in the wintertime before. I've done that. In fact, I did a latex balloon with only about 1 pound positive lift, or half a pound positive lift, 1,000 gram. And we went from Idaho to Newfoundland, off of the into Newfoundland. No, I guess off the St. Lawrence Seaway is where we went. I guess about a day and a half to do it. And get it back. We managed to float on a latex balloon. Bill had kind of designed that I guess Bill, you discovered that. We followed it, and latex balloon across the United States wasn't too bad.
Well, I guess there's no way on the big balloons you fly. There's really no way to stabilize those at a certain float level, is there? I mean, they're just going to expand.
Yeah, there is. Yeah.
Is there a way you could do it?
Yeah. Go ahead, Paul.
Yeah, so Bill kind of discovered this, but if you put in very low positive lift, and then you launch, you kind of wait kind of late into the evening so that the balloon will kind of be at some altitude before it'll burst, and without much positive lift, and the sun sets, the balloon, the gas inside gets cool, it contracts a little bit, and you don't have quite the lift, and you'll stay there overnight. In fact, we did overnight plus about almost another day after that before the balloon degraded enough and we came down again.
But I guess it would be difficult with that type balloon to stay up a week or 2 weeks. Is that right?
A couple of days, I guess, is the max, isn't that?
Yeah.
Days.
Yeah, the UV rays from the sun's UV rays degrades the latex, and usually the longest flight I've seen as an intentional floater. I first found this out by accident because I went up really slow, about 200 feet per minute. You normally would go about 1,000 feet per minute, and I had a really lightweight payload of about 2 pounds, and it stayed up all night long. And I launched it right before, a couple hours before sunset. So right at sunset, it leveled off at 90,000 feet and stayed there all night. And it ended up going west and landed in Texas from Alabama. It went 800 miles to the west because during the summer months, the winds in the stratosphere are usually opposite what they are here. They're out of the east. Mm-hmm. So, but K6RPT from San Jose launched a little 5-ounce tracker on a big, you have to have a fairly good sized balloon to make this happen, but you can do it intentionally. And they're called latex floaters. And he got one to go from California in the dead of winter So we didn't get a lot of UV radiation, and he got, I think it was a 2-day flight, maybe 3. He went all the way from San Jose, California to near Casablanca in Morocco, and he got it back.
Amateur radio community anywhere around the world to help you out.
Yeah.
They had to negotiate because in Morocco, possession is 100% of ownership, so he had to buy it back. But he found some hams that were in Casablanca that drove out to the date fields, and they negotiated and they got the payload back. But that's the amazing power of APRS, how universal it is around the world. So that makes it easy to track things even as you send one around the world. But I've done a number of them. We just had one that was done by accident from Clarksville, Tennessee. KD4DTH sent one up. He was going up about 100 to 50 feet a minute with a 2-pound payload. Ended up in Texas. Oklahoma, I'm sorry. It landed in Oklahoma. And we tracked it all night long.
All right. Well, hey, let me make a quick announcement here, and we'll be right back. I just want to mention to anybody out there that's listening to us on shortwave, we'd love to hear from you. We're on WBCQ on 7490. This is a very famous international shortwave station. And we've recently moved up to this frequency of 7490. We'd love to hear from you, find out where the signal's getting into. Send us a email to tom@w5kub.com, tom@w5kub.com. And you've been listening to a ham radio program. This is about ham radio, amateur radio. And again, if you're interested, you can tune in on the internet. If you have internet access, you can tune in to or go to w5kub.com and watch the show, and we'd love to have you. All right, we're back. I just wanted to get that out there and see if we could nudge a few shortwave listeners, Bill, around the world to shoot us some emails.
There was a question in the chat room about what part of Idaho you're from, Paul, because there's a fellow that is also in Idaho.
So the town is Homedale, just outside of Homedale. This is southwest Idaho, close to the Oregon border, southwest Idaho. So about 30 miles west of Boise. So Homedale, just outside of Homedale. And town I actually live in is Wilder, but we're closer to the town of Homedale.
What time of year do you generally do most of your flights, and do you do many flights for students?
Well, right now with COVID, we're not doing anything, unfortunately. So typically, starting from spring until late fall, I typically will stay out of flights in the wintertime, only because we get snowy and cold out here. Like we've been dealing with some snow right now. We had about half an inch yesterday, and there's some more snow and fog today. But I'd rather not launch and chase in this really cold weather. So typically, spring until autumn, sometime in autumn is when I'll typically fly.
Yeah,
However,
but think how much easier it is to find them in the white blanket, not have the corn 17 feet tall.
Yeah, that's true. The problem is we have to usually drive off-road into the desert, and I don't know what kind of traction I have when it's icy, snowy in the desert. So it's bad enough with gravel. Half the fun is waiting for a tow truck to get me out.
As I sit inside in the nice warm heat.
Yep.
All right.
Springtime, this summer and all that, that's much better out here. It's a lot more fun when the weather's warmer.
Take a camera and I'll watch.
All right. Before we run out of time tonight, I wanted to give an update on what we're doing with our EME stuff, guys. We're not moving very fast on our EME stuff right now. I do have the WSJT-X set up on a computer here. We did, as we talked about last week, we put a camera on the end of one of the Yagis out there. So when we do aim it at the moon, we can see the moon down here in the shack. So we did get a camera mounted there. I'm a little worried about trees. And one of our viewers does a lot of EME. He says, "Don't worry about these trees." He says, "I got the same trees," and he says, "I'm working hundreds of people all over." But you can see this is what, for my antenna, that's right below the antennas. You can see the trees that I'm going through there. I'm very blessed to have trees. These trees are 80 to 90 feet tall all around my house. So they're great for putting up wires and wire antennas, but of course, when I get leaves on it, it's not going to be so good for EME. So if you look closely there at the top of the picture, you can see a UHF and a VHF Yagi there on a rotor up there. But that's what I'll be shooting through. So we're going to have to go through the trees to the moon. We got a camera now that we can help, position it. There's kind of looking at it, up the boom there, the camera here on the back end. Let's see what else we got here. How many people have camouflaged beams? Do you have one, Glenn? Are your beams camouflaged?
No. I'm looking at that though, but shouldn't they be painted like sky blue?
Well, no, actually, because see, that's just right on my roof, and when you're going up and down the road, you see all this stuff in the background. See that right there? You're seeing all these trees and leaves in the background of the antenna. Therefore, the antenna is camouflaged, and it blends in really well. You can't really see it that much there, actually.
Now, you see, I live in Mississippi, so I can hang anything I want out there.
That's true. That's true. So anyway, we've got our antennas again. We're trying to do this low end, single Yagi. I was told by this guy that does so much EME. He says use 2 meters. Don't do 440. He said let's do 2 meters. He said you'll have much better luck. So okay, I think we'll try 2 meters there. So the problem I've got now is I've got a roof that's on a flat. Those Yagis are on a flat porch roof back there. So to the west and to the south, I've got actually a roof that blocks them down at a low angle, a low elevation. So I've got to wait for the right days for the moon to be in the right part of the sky, for me to aim at. So our plan here is to try, the JT65. We'll try 2 meters, and we'll try to listen first to see if we can hear anything. If we can't hear anything, probably not not worth trying to transmit if we can't hear anybody. But hopefully we'll be able to pull somebody in and hear them. So that's the situation there on the EME. We're moving on it, not very fast. Hey, last week we talked about the spherical antenna, and many people didn't really know what a spherical antenna was. And I mentioned that we built these back in the early 1970s. We homebrewed them for C-band, and we watched, the C-band satellite stuff. And I mentioned the feed horn, and here's what I was describing. This is this feed horn was actually a piece of sheet metal. We made a horn. Right behind it, we had an LNA, and then you notice the antenna rotor. And that antenna rotor basically turns that feed horn 90 degrees, either horizontal or vertical. It turns the little antenna in there either horizontal or vertical. And that's how you got, your even channels or your odd channels on satellite, on C-band. Here is a spherical. This is a 20-foot spherical, which someone here in the area built. It's equivalent to a 25-foot parabolic dish. This is not a parabolic. It's got a smooth radius curve to it, and it's a spherical. In fact, the more I looked at these here recently, I noticed that a lot of military installations actually had these antennas, and I didn't realize what they were back then. But this was built with angle iron. Let's see if I got another picture here. That's me standing in front of, that's probably a 12-footer. So these were actually built with angle iron. You can see this is not a good picture. when we did this, we didn't have digital cameras, and I looked and looked, and I could not find any good pictures anywhere. And I found this this kind of article that I wrote, and I had these pictures here. So this is all I can find right now. But the construction of the spherical antenna was, you can see there's a it's an angle iron frame, and then it had wood. We had 1x4s wood in there, and they had 6-inch long bolts. The bolt went through the wood and into the angle iron, and we used that bolt to pull in the wood and make it the curvature, make it the radius. And the feed horn sets 1.5 times the distance out in front of the dish, or the spherical. The spherical does not move. Once you set it, it does not move. And you get the different satellites by moving the feed horn different spots. In other words, SATCOM F1, or whatever it used to be called back then, the feed horn may set at this spot on the ground marked X, and we'll adjust it up, maybe 4.5 feet up. And if you wanted the next satellite, you move the feed horn over maybe to the next spot on the ground, and you might raise the feed horn up to 6 feet, and so forth. So we actually moved the feed horn and not the dish, or not the antenna itself. Anyway, that's what the spherical antenna was about. I found those few pictures, and I wanted to show that to you guys this week. And that's about it on the updates. Glenn, was there anything special you wanted to talk about tonight?
No, not tonight. I showed off the RTTY reader, which is the big project I've got right now.
Okay.
And that will be in the next book.
All right, very good. Well, Alan sent me a note. He's got some type, I think some type minor emergency there at home, with the kids. Who knows? It could be, broken finger, a skint arm, skint knee, who knows what it is, but he was unable to make it tonight. So I think everything's okay. He didn't say it was anything serious, but it was something that he had to deal with tonight. Guys, that's about all I've got here. What do we want to talk about the next couple minutes here? Bill, you got anything going?
Yeah, I noticed in the chat room somebody said if you have a beeper on a balloon payload and it's landed in their field, wouldn't the farmer shoot at it? Well, a group in Texas launched a expensive video camera, and all kinds. I think they had several $100s worth of electronics in it, and it landed in a farmer's field, and they had a beeper on it. This is in Texas. And when they arrived at the coordinates, they observed a farmer with a .22 rifle shooting at their payload from about 20 feet away. And they waved him down and says, whoa, what are you doing? He says, well, I thought it was a bomb, so I decided to shoot it.
Oh, yeah.
Now, do you think that's a wise idea to shoot a bomb from about 20 feet away?
Oh, yeah, in Mississippi, that's called target practice.
I don't know.
Unfortunately, one of the bullets went right through the camera and blasted it. But everything else was intact. But their payload had all kinds of holes in it.
So it's like putting nails in a truck carrying ammo, right?
Yeah.
What you need to do is put a voice synthesizer on it instead of a beeper and have it counting down.
A friend of mine, Mark Connor, said when one lands in someone's yard, you go knock on the door and you'll say, hey, you didn't touch that, did you?
Yeah. Ask them if they've seen the Andromeda strain.
Yeah, I figured we just dressed up in a hazmat suit and go knock on the door.
We had one land in a woman's yard in Georgia, and it was a pretty good sized balloon. It was a zero pressure plastic balloon, like the type you fly, Tom, only a lot bigger. And so this big silver thing comes down and lands in her kudzu patch, and she called the police, she called the TV and radio stations saying that a UFO had landed in her yard. Of course, they all ignored her. But 5 minutes later, our chase team knocks on her door, some of whom looked like aliens, and it took a while for her to open the door and recover. Then we had one land also in Georgia on a farm, and it was 90 feet up in a tree, and the farmer said, well, I don't mind if you go back in there. And we looked at the tree. He says, hang on a minute. And he came back with a chainsaw, and he says, you all can cut the tree down if you want. So we chopped the tree down. It fell down. We walked up and grabbed the payload, easy peasy, out of the top. And he says, now, if you don't mind, can you cut it up in about 2-foot logs and stack it up by the house? Which we did. So he had firewood for the season already set. And then as we were leaving, it says, I just picked fresh okra from the garden, $10 a bag if you, and we felt obligated to buy. So he said, you all come back now anytime here.
Up in a tree. Let's see. I got a picture here somewhere. Yeah, right there. See those guys right there?
Yeah.
That's your friends over in Poland. That's Poland, right? Yeah.
Right.
That's the Polish Ham Club that went up the tree and rescued one of our flights here this year. Man, has COVID got them turned off? I'm hearing nothing from those guys.
They were planning on relaunching it, but they're pretty well shut down. They got another surge of COVID over there. So.
Man. Well, and they were. I don't know how they got it down. It was up in a pretty tall tree.
They had a slingshot or crossbow. I'm not sure which, but they were pretty accurate at it.
Man,
they do a lot of balloons in Poland, so
yeah.
They were pretty used to landing things in trees.
I guess if you shoot a line through the balloon and it has a line, you could pull it down, maybe.
Well, I think I've got a tree sensor on all my payloads, because there could be an open field of several thousand acres and one tree in the middle, and I'll land in the top of that tree.
Yeah.
Well, again, I'm back to the drone thing. Can't you just take a drone with you and have a little drop line and hook up to it and pull it out of the tree?
There
was a group in Germany that did exactly that. Their payload landed on the other side of a sign with had barbed wire fence, and it says entrance verboten. And they got it was a pretty heavy duty drone, and their payload was light, and they put a hook on it, and they flew it over the fence, and they hooked their payload and brought it back over to the other side. So it can be done.
Well, Russ has got a question. Russ has got a question in the chat room. It says, can a big balloon be filled with less as to not burst at 100 feet or 1,000 feet? And I think we talked about that a minute ago.
So it sounds like we want to just take the balloon up to altitude and then vent excess gas once you get to altitude before you burst. And that's done commercially. Near Space Corporation, and there's some other folks who are sending balloons up for radio communications will do that.
Well, how about the Loon? Is it Loon?
I think Loon. Yeah, Loon I think is one. They actually will send up balloons and then get the altitude you want, and then they'll vent gas or vent weight, keep the balloon at that fixed altitude. And
that thing's staying up for quite a while. So I think, I mean, I don't know what the life is on it. Do you have any idea?
They have to carry ballast, which they drop off every night. And I think the limitation is probably 5 days.
Oh, you think it's a max 5 days?
Yeah. Although the Loon program's a little different, because the way they do it, they can stay up longer than that, because they actively bring air in and out, pump it out. So it's kind of like
that's a pretty big balloon that's up there. Man, if that landed in you, that landed in your yard, it'd be a big surprise, I'm sure. Yeah.
So I did a cheap version of that with a standard latex balloon. Is that I put a little PVC pipe in the neck of the balloon, and I drilled 2 1/8-inch holes in it to continually vent gas, and it floated. But the next day the sun got it. But that's another way to float a balloon.
Well, I guess at some point though, when it all escapes out, you eventually get to the point where you don't have any gas left, right?
No, it's
Or-
actually floated. It actually floated. It didn't
did-
have enough pressure to release any more gas, so it
Oh.
actually floated at 110,000 feet.
Okay.
The gases can still escape that latex. It's slow.
Yeah.
You can still vent gas.
Yeah, I've noticed that the latex balloons, it's a pretty leaky membrane. I've been trying to find some, like the SBS balloon we're flying. It's it's a gas barrier membrane. I think it's multiple layers, and it's about the best that I found. I can't really find anything to make a balloon. I wanted to make a bigger balloon, but all the material I'm able to get my hands on, it's going to be leaky. It's going to leak through it.
For toy balloons, the latex balloons, if you go to a florist, I think they have a liquid they can spray inside the balloon that makes it a little less leaky. I don't know how long it lasts, but I think the balloons will last longer with that where they spray that little liquid inside.
Yeah, and I've seen that on the internet to buy that stuff that coats the balloons. I'm not sure what kind of weight it adds or what it does. I don't even know if it would actually be consistent and cover the inside good. It might only hit 80% of the balloon, but that may slow it down. Yeah. All right,
Yeah, but
guys.
you
Well,
need to
it's
focus on
about time to call our show off because we're hitting about the 2-hour mark here. I want to thank everybody for being on here with us tonight, and tune in next week, same time, same place, w5kub.com at 8 p.m. Central Time. And if you want to join us on our 40-meter net, it's at 5:30 p.m. Central Time, and it's usually on 7180. If you're out there listening again on WBCQ, on shortwave on 7490, send us an email to tom@w5kub.com, tom@w5kub.com. We'd love to hear from you. All right, guys, I'm going to say good night to everybody. Good night, everybody. Thanks, everybody, for joining us there.
To see you again, Bill.
We're gonna put Glenn on here for the closing. Here we go.
Yeah.
I swear I'm going to get some aluminum foil and put them on this gas.
You can hang in there for a few minutes.
I don't know if it
Paul.
ran or not. Let's see.
He's just doing
Well,
the closing.
I can't do it. It's not running. Okay. All right. Good night, everybody. We'll